So I'm hoping everyone is doing well, inshallah. So we are already going into this week 10, I believe, out of the 14 weeks. So time flies. And we only have basically 5 weeks, including this week, of material to cover to complete the course. And this week we are focusing on chapter 10, right? With regard to moment of inertia. So you will notice that there are similar elements between chapter 10 and chapter 9, where we deal with integration, and in the next class we will also deal with composite area or composite volume. um, though the mathematical concept that we use is similar, where we also still use integration, but the equation is different. Make sure you are clear with that. The equation we use for centroid is different than equation of moment of inertia. That's number one. Number two, uh, the concept of integration is still the same, where we divide into elements and we integrate, right? So we can have vertical or horizontal element. However, however, I think one fundamental difference that you may notice, you should have noticed by now, is that when you calculate with or to calculate centroid in chapter 9, um, it's up to you whether you want to use vertical and horizontal, and the equation will still be the same, and your integration will still be the same. It's just that, of course, depending on the shaded area, how it is, you might have a bit more complex in the sense that you have something minus something, right? Depending on the region itself. But the integration itself is the same, meaning the equation is the same, and just select whichever element, the answer will also be the same, of course. But for moment of inertia, you should understand by now that if you use vertical element or if you use horizontal element, the equation will be different, right? The equation will be different. So that's number one. So if you match a different element with different equation, then from the get-go you will lose all the marks, because all the calculation will become invalid, right? Because for example, for ix, if you want to use the generic equation, you will have to use horizontal element, for example. If you use vertical element, then you have to have the integration of dix. And dix you can find or derive from the parallel axis theorem, right? I think we have covered this in the lecture. If you have covered the lecture, you should already be familiar with this by now, right? So that's the important thing, just to highlight. Make sure you really understand which element pair up with which equation. And another mistake that I noticed, that many students, they simply, if you want to use the parallel axis theorem to establish the dix or diy, do not simply memorize, because for that 1 over 3 bh cube, for example, is derived based on the axis is at the bottom of the element, right? So if the axis is anywhere else, the equation will be totally different. For example, if the axis is at the middle, it become 1 over 12, for example, right? So I think we covered that as well, where I illustrate how it becomes like that. So make sure you understand and do not simply memorize, because then if you start from the beginning, your equation is wrong, then the whole marks will be gone, and that will be quite detrimental, especially if that happen in the final exam. In the final exam, for sure, chapter 9 and chapter 10 will come up. Although which question will give you the integration, it depends on the lecturer that prepare the exam question. If you look at the past exam, in some exam, chapter 9 have integration, chapter 10 have composite area. In some exam, is the other way around. Chapter 10 give you integration, chapter 9 You need to find using composite. In some exam, it combine both, meaning that both chapter 9 and chapter 10 have integration, for example. So it depends. Um, but for sure, at least one integration question will be there. Yeah. So again, just to reiterate, make sure you understand first and foremost which equation pair up with which element, and second, if you have to derive the parallel elasticity theorem or you just simply want to use it, make sure you understand where you can use it for that 1 over 3 BHQ. All right. So that's the common mistake that I can recall, because it happens again and again every time. So hopefully you are mindful of that. Other than that, I think it should be straightforward, because normally the easiest question to secure full marks is from chapter 9 and chapter 10, because uh, there are no really trick question that they can give you. I don't think. It's just that sometimes the integration can be a bit long sometimes, but it is straightforward, meaning that if you understand, then it's just a matter of calculation. Right? Compared to other chapters where we can give you, for example, in 3D problems, etc. Um, various type of question that we can give you, but for chapter 9 and chapter 10, at least for the syllabus that we have, because we actually, if you have the textbook, there are portion that is not included in the syllabus, right? uh, the common mistake, oh okay, so just to repeat if I can remember, the common mistake one is, I think the mistake in pairing up the element and the equation. That's one. Because for moment of inertia integration, you cannot just pick one element and just use equation that is not valid for that element, right? So that's number one. And in the lecture, I've shown which element is for will give you which equation, right, for Ix and also Iy. So that's number one. Number two is if you use the integration of dix or integration of diy, do not simply blindly memorize that it is equal to 1 over 3 bh cube or 1 over 3, for example, y cube dx, for example. Right? Do not simply memorize it without understanding why it becomes like that in the first place. It's up to you whether you want to derive it or not in the paper, in the exam. Normally, there's no mark for that, because you can simply just memorize if you understand. But the importance of the understanding is that you will not, because for some area, it will not become 1 over 3 BH cube. So that's number two, the common mistake, that the students simply just apply that 1 over 3 BH cube there when it's not 1 over 3, when the axis is somewhere else. So that's the second common mistake, I think, for this particular topic, right? For in moment of inertia using integration. That's the two most common, I think, for the moment of inertia for integration. There are the mistakes as well that not that common and should not be common, which is, for example, if you make a mistake in terms of taking the limit, that shouldn't happen, because if you understand what's going on, you know what's the proper limit, right? But actually, the common mistake should not happen as well. But because I see that again and again, so I think it's common for students that tend to memorize and do not really understand why. So yeah, make sure yeah you understand why, or even if you memorize, you really memorize the reasoning as well, so that you will not make that mistakes. What else? I think that's the main thing. As long as you know the equation, the element, because the element is important, because you will have the expression of dA equal to something, right? Yeah, another thing is, I'm not sure why some students still make the mistake of, when you have the element and dA equals to something, uh, I'm not sure whether some student memorize or something, when you have, for example, y minus something, right? Or 4 minus x, 4 minus y, or whatever. I really hope you understand why it becomes like that. Why is the expression that? Why is it just x dy, or why is it 4 minus x dy, or anything, right? Because it's logical. If you know what's going on, it's logical, right? But in the quiz, in the past quiz, many students simply just make mistakes there. That is, I'm not sure why, what happened. I'm assuming they memorized. I'm not sure why. Because if you understand why is it this minus this, it's almost impossible to make a mistake, I think. But it still happen a lot in the quiz. So if you are confused in any of those, please do ask and do not assume and gamble, right? So please do ask, and because I'm here to answer anything that you are not clear with, so make sure you ask. But if you are clear, inshallah, hopefully, yeah, two things. One is the quiz. It's is the best opportunity to secure full marks, as well as in the final. The normally in any final, the easiest question to get full marks is if chapter 9 comes up for the composite. That's the easiest one, because you just make a table and fill it up, and then you get the equation, right? That's the past, the previous quiz. That's the most easiest one to get full marks. The second is actually integration for those who understand, because there's not much trick question that you can do there, compared to any other equilibrium problems. Wallahu alam. So that's just some reminder, so that if you any of the thing that I mentioned you are not sure of, please use the time after this to make sure you understand. Yes, if you have a question, you can ask.
Sir,
Yes,
do you have the answer scheme for the quiz on last week's Tuesday about the centroid?
the answers. Okay, yeah, yeah. Normally I'll post because I'm because I just finished recently the marking for the midterm, and then I'm turning my focus on the quizzes. So normally once I have grade the quiz and send all the quiz back to you, that will be the same time I'll complete the process of putting the solution for each quiz. So yeah, I think it should be today, because I'm finishing my marking and sending out the file, but it perhaps later today. Yeah. Uh, why do you need it for today? For
Uh,
meaning this
no, really. I just want to
see
check
whether
my
you
mistakes.
okay. Hmm. Okay. Anyway, so we will see, because that one I'm not sure. It depends on when I finish it, and I will straight away email it, because I'm in the process from today from 7 a.m. I'm emailing it back to the student one by one. So we will see. Um, Anyway, any other question? I think I have mentioned all the things that you should really understand with regard to this topic. Okay, if no, so as usual, I'll be here on standby. Please do ask any question on this topic, or on any other topic as well, right? Because in terms of the integration in the last quiz, um, I noticed that many students managed to get full marks, but there are still some students that totally get it wrong from the original equation and totally get so low marks. So if you're confused about anything, please do ask, because yeah, today's quiz is also about integration, where I think the trend tend to be the same, whether you get full mark or quite low, because the mistake can normally happen very early on, and then the whole calculation will be affected, right? So if you get the correct equation, integral equation initially, as long as you know how to integrate, then you should get it right, unless some mistake happen, right? Okay, so wallahu alam. So I'll be here as usual. Sure, sure. If you want to ask, feel free.
May I share the screen, sir?
Sure.
May I share the screen? Hello, hello. Can you hear me, sir?
Yes.
Okay, so I just want to ask about question number 4. I don't know why,
Mm-hmm.
but I think my equation is correct. So, um, jap. No. So this is my answer. Can you guys see my screen? Can sir see my screen? Okay.
Yes.
Okay, so for this one, sir, um, I'm not sure why is it wrong for me to use the y prime axis because I make this new axis, right? Y prime and z prime. So my prime it is wrong. I don't know why, but I checked the answer yesterday. It is correct for 100. So can you please explain why?
Okay, let me see because I'm not marking for question. I mark for question 2 and 3, so I have to. So I'm not that familiar with this question. Okay, let me see. So it is written the 400 times. I do not see the number. That
Uh,
one is correct, and then 400 times the other thing is correct, and then that FCZ is round. So I think the lecturer
Maybe
mark it.
I
Yes.
forgot to put one, sir. Only this part I forgot.
Okay. So it will appear from the methodology. It will appear as if you just put the force there, right? Is it?
Yes. But for this one, it is correct. MZ prime, FCY1. But why is it is for false? And also,
Uh, go back up. I'm for F. Wait. Yeah, which one do you do? MZ,
MZ prime. MZ prime, this one.
MZ prime. Okay, so all the forces are vertical, is it?
Only FCY related to MCZ prime. So
Okay.
FCY1 equals to 0. Why is it wrong?
Mm, okay, it doesn't seem. I'm not sure whether the lecturer didn't realize that you put Z prime there. That's I'm not sure. Um, but your problem is for the moment, right? For the FY there, is it?
FY it's also 0, so actually it is correct, but I don't know why it is wrong also. And for FZ pun sam FZ is the same. It is actually correct, but I don't know.
FZ
FDZ.
400. Now, by the way, when you refer to the answer scheme, it, it should be correct, is it? Meaning because
Uh, yes, the answer is
no, I'm
FC.
not saying not asking about the answer. No, because normally, some lecturer when the method is wrong, then they do not even look afterwards.
Oh, actually, I just put the Z prime and Y prime because it only has one. For the scheme, it has two unknowns, so a little bit different from the scheme.
To unknown.
Yes, from the scheme with. Uh, uh, um, um, yeah.
Is this a bearing or something?
For the question for bearing, yes. So,
But of course, you can specify the question, and I can many for example you personally message me on Telegram or something, then I can forward the question to the lecturer if you think any point is a valid mistake in term of the marking.
this one, sir.
Mm,
The answer scheme used
okay.
only Z and Y exists, but I create another axis z prime and y prime. So is it acceptable?
It should be if in the diagram the axis is clear, and then you use that one. But where is Fy? There's no Fy here? Oh, that C. So what's the difference between this and yours? That Fy
Uh,
that you get it
it
wrong?
is just the equation. I use mz prime and my prime. That's
Okay, no, meaning you're talking the mistake is just for the moment, right? Because
yes.
meaning that the Fy is not mistake.
Fy also fy fz.
Fy.
The answer is the same, but the method is different because I use y prime and z prime.
No, but Fy, Y prime or Y should be the same, right?
Um, yes,
Force, not for moment. For force.
yes, first is the same, 0 and 0.
Mm,
I
I'm not sure what, because this one perhaps is it the case that because CY you already established zero and then you write straight away zero there that he didn't realize. Mm, because I can only speculate as of now because I haven't gone through this question. But if you have valid reason to think that it is a mistake, please do send to me the
uh,
specific with your specific metric number, etc., so that he can also look at the file that he marked and which part that is the thing with the explanation why it's a mistake. I will forward to the lecturer.
sir, actually I've asked yesterday, but I just want some confirmation about my wrong equation because I think it is correct just because I use z prime and y prime.
Wait, you asked yesterday for,
Question 4, this one.
but you mentioned only for because you asked the missing one, right?
Yes, missing one. But the reply is the working is wrong. But when I check it again, my working is correct.
But okay,
So
the missing one I think is only for that my prime, right?
my prime this one. But the others
It's not
they're
about
working.
mz. But because you didn't ask for the mz prime, so that's a different question. But for okay, for my prime, my assumption is because for me, if I look at it, you will lose mark at that fcz lah,
Hmm.
because you didn't multiply by anything. Um, I do notice in the midterm some students do not write when they should multiply by one in calculating moment. They do not write. Actually, that should be wrong because we can only understand what is written, not is what is intention, what your intention is. So for because what I forward is just for my prime, not was with the regard with the anything else. So if you want to further ask for, I can request again, meaning the is it because didn't multiply by one for that one. But from the response and just looking at this, I understand why he said the method is wrong lah.
Oh, so is it just because of one and then the rest is also wrong, sir?
Okay, the issue is because I know the student always focus for the final answer, but the lecturer always focus on the method because
Mm.
if the method is wrong, we consider the final answer if it's the same is coincident. It's not you get it right. It's just kebetulan betul, and you do not deserve to get the mark. And that's some approach will be like that. So um, so that's the thing. So from here, we can ask again, but you have to rephrase the question. That's for my, but for mz prime, I'm not sure whether he didn't realize uh, the z prime. If he assume it is calculating using mz, for example, because mz, I think the equation will be different, right?
Yes.
Okay. So you can further send the, meaning the question sentence should become from you and I just forward it.
Oh,
So
okay,
you
sir.
can just, all right.
Thank you, sir.
Okay, welcome.
Yeah, I have a question. I'm still not clear about this. So, about the parallel axis theorem and the DIX. So, when will we know that we need to use the parallel axis theorem, or we need to use the 1/3 y cube or x cube, or is it both just
Okay.
the same?
Now, in terms of which equation for which element, is that that part, is it clear?
Yes, yes.
Okay, so the parallelism theorem comes in when you use the integration of dix or integration of diy, meaning to get the expression for what is dix and what is diy. If you use that element and that equation, you will use, meaning the parallelism theorem is to derive what is it, meaning is it 1/3 bh cube or something else. Meaning that 1/3 bh cube comes from parallelism theorem, if you understand. So, so by definition, when we use integration of dix or integration of diy, you will have to use parallelism theorem. But whether you show the detail of parallelism theorem, that's a different story, because for many cases you can simply just memorize that parallelism theorem will give you 1/3 bh cube, for example, for cases where that is valid. So going back to your question, when to use parallelism theorem is on that cases. Is that clear or is not really answering your question?
What about the 1/3 y cube and or one
One.
over three from the DIX, right?
Uh-huh.
Sometimes we in your tutorial video, sometimes that I think the second version, if I'm not mistaken, you start to use DIX equal to 1/3 y cube or x cube, or DIY equals to 1/3 y cube,
Uh-huh.
instead of
Okay.
using the parallel axis theorem.
No, that 1/3, if you parallel theorem give you 1/3 bh cube or 1/3 hb cube, depending on whether it's horizontal or vertical. And because the element, the for example, if you have a vertical element, the the base is dx, right? And the h is y. So when we have bh cube is dx times y cube. Hence, that's why it becomes 1/3 bh cube becomes 1/3 y cube dx. For that part, do you understand? Meaning that when we say using parallelism theorem, it leads towards that 1/3 y cube dx.
Okay, so
Meaning that
but the DIX, but
dix, okay.
we know that the parallel axis theorem, like sometimes somehow we get like 1/12 bh cube plus bh, I think ADY, right? ADY, if
Yeah,
I'm not
yes,
mistaken.
correct, yes.
So why about the 1/3? Why it doesn't have any like, or like
1/12 plus something too.
yeah.
No, okay. Okay, just imagine for the specific case of you where you have a vertical element where the base is dx, the height is y, right? You can imagine, or you can sketch
Yes,
it
yes, I
down.
can imagine.
When you use parallelism theorem, it is basically ix prime, which is 1/12 bh cube, right? 1/12 bh cube plus a dy square, which is plus a is b times h times uh, I'm sorry, dy square, right? Meaning that h/2 bracket square, right? So if
Yes,
you solve that, it become 1/12 bh cube plus, because you have square there, it becomes 1/4 bh cube, right? So if you have 1/12 bh cube plus 1/4 bh cube, if you plus, it become 1/12 plus 3/12. When you plus, become 4/12 bh cube 4 over 12 equal to 1 over 3, right? So that is where you get 1 over 3 BH cube when
Oh,
you
I see.
solve the parallelism. So meaning that 1 over 3 BH cube is not just memorized, it's actually derived from the whole ix prime plus a t y square. It comes from there.
Is it applicable? Is the 1/3 y cube or x cube applicable for every cases or no?
No, because when we did the calculation just now, it become 1 over 3 when dy square is h over 2, right? When dy square is, no, not dy square, meaning dy is h over 2 because it's the distance between the x prime and the bottom is half of h, right? So when it only valid for when axis is there. If you have axis elsewhere, dy will be something else, and it will be not 1 over 3, it will be something else. Because when you calculate that 1 over 12 ph cube plus a dy square, when dy square changes, obviously the result of that summation changes. So 1 over 3 is only and only when dy is h h over 2, yes, half of h, where it means that the axis touches the end of the element, the either the bottom or the top. If the axis is somewhere in the middle, or it's actually meaning there's a gap between the element and the axis, so it will not be 1 over 3, it will be something else. You have to derive the whole thing.
Right. Thank you, sir.
Okay, welcome. Okay, so there's a question: when we draw the element, it must be in the middle of the shape or just random? You're talking about when you solve the exam, is it?
Yes.
What do you mean just random? Random meaning without the full graph, is it? What,
Yes, sir.
either way. If you just draw, meaning just draw a rectangular, simply just rectangular shape, and then you just describe that side is dx or dy, that side is y or x or something minus something, that is also understood. Normally for explanation in the class or etc., I draw first in the middle of or in the region of the shaded area to make it easy to understand why is it y or something minus y or something. But for answering the exam question, for student that needs to draw like that to be able to get the correct, correct dimension of the element, it is advised to do so for your own benefit. But if it's already understood, you just draw the element and indicating the sides. That's sufficient. If you do not need to redraw the whole plot, not necessary, not required.
Oh, understand. If we not draw, does the mark deducted?
Not draw which one?
Not draw the shape.
Meaning totally do not draw, is it?
Yes.
Okay. If you totally do not draw, okay, the required thing or compulsory is it should be clear cut which element you are using. So some if you actually write taking horizontal or taking vertical, at least even if you do not draw, at least we can follow what's going on, meaning okay, you consider this element. But if you do not indicate anything, if you do not draw, you do not write anything about horizontal or vertical element, suddenly you use certain equation, and especially for moment of inertia, because moment of inertia, the equation itself depend on the element. So we do not know whether that is right or wrong, because if you use the other element, then it will be wrong. Yeah. So normally which element you choose to use, it is needed to be specified to get any mark. If you do not have any indication, there will be no mark normally, because it is not understood where you get anything from. But if you indicate without drawing, at least the element is clear which element you are using. But in terms of the methods, normally when you draw, it is quite clear where you get that, meaning how to say, the X and Y or etc. If you do not draw but you still say, for example, dA equal to something after you state what element you are using, maybe it still is going to be accepted. I cannot guarantee depending on the different examiner, but at least we can assume the understanding of what is going on. Yeah, but if you never say anything about any element, normally that will not be accepted.
So understand? So we have to define what we want to calculate, right?
Yes, because any how to say, for example, if you are talking about centroid, the equation is fixed. Whatever element you use, the equation is fixed. So if you do not specify the equation, for example, you will miss that mark, meaning the equation mark. But if the continuous the steps after that is correct, you still get the steps, the mark for the steps, but you will miss the mark for the equation. But for moment of inertia, the issue is because the equation depend on which element. So so that element becomes required, because otherwise whatever comes afterwards is yeah, meaning perhaps the student understand, but I always emphasize that in terms of examination, we cannot assume anything. So we have to be based on what is written, so that the critical information must be there. It's just like if for equilibrium problem, if you do not draw any free body diagram, we will just ignore anything that you calculate, because how can we judge what is what, right? Meaning that even though it may be correct, but if you can imagine any type of free body diagram, when you calculate moment, right? So obviously, for if you draw separate reaction, some student may, or someone may assume force upward, some assume force downward. For example, for anything like pin or etc. Right? You have X and Y, so some can use right and up, down and left, or whatever. So your equation, the marking of the equation afterwards, based on that free body diagram. So for some student it will become plus, some student will become minus, depending on their drawing and right. So but with that, if the drawing itself is not there,